Okay, this is Unit 4, video number 6, double replacement reactions in practice. So I'm going to just solve some double replacement reactions here, and hopefully that'll help you out. One of the things to be aware of when we talk about double replacement reactions, we're switching the cations. Okay, these are strong electrolytes, so they dissolve well in water, and we're going to switch the cations. So nickel chloride here, this is actually nickel 3 chloride. Chlorides are generally soluble. Nickel would not be an exception to that. Cobalt 2 sulfate. Sulfates are generally soluble. Cobalt is not an exception to that. So these are both aqueous. So in water, they're going to produce nickel ion, cobalt ion, and then we're going to make our anions, chloride and sulfate. So what we're interested in is the combination that's not what has been written. So we're switching the nickel and the cobalt. Nickel with sulfate is going to make nickel sulfate, Ni2SO4 3. Sulfates are generally soluble. Nickel is not an exception to that, so this compound is going to be aqueous. Then we're going to have cobalt with chloride, CO plus 2 and Cl minus, going to make CoCl2. Chlorides are generally soluble. Cobalt's not an exception. Those exceptions are lead, silver, and mercury. So this is also aqueous. So if when we're done, we have aqueous, what we have in solution is nickel ion with sulfate, and then cobalt ion with chloride. We have not actually done a chemical reaction at that point, okay? All we've done is rearrange the ions. We have the exact same set of ions. So this is no reaction. Go down to the next one, potassium hydroxide, reacting with strontium chloride. Potassium hydroxide is a strong base, very soluble in water, because potassium compounds are always soluble in water. Strontium chloride, chlorides are generally soluble, exception to lead, silver, and mercury, not strontium, so that's aqueous. So we're going to switch the cations. We're going to switch potassium with strontium. We can draw out our ions here. We're going to have potassium ion, hydroxide ion, strontium ion, which is a +2 ion, and chloride ion. When we do that, we're going to get KCl. Potassium compounds are always soluble in water, so that's aqueous. Plus, and we're going to get strontium hydroxide. Hydroxides are generally insoluble, so we'd expect, this has a slight solubility, but we'd expect that to be a solid. We're going to have cloudiness in the solution. So as we come back over here now, we have potassium and chloride floating around, but we do not have strontium and hydroxide floating around. We have solid strontium hydroxide. We have solid strontium hydroxide. We would have to balance that. We're going to have a 2 here and a 2 here. Let you work through that balancing. Okay, and the last one here, we got nitric acid. That is a strong acid. That's going to be aqueous. Reacting with barium hydroxide. Barium hydroxide has slight solubility. We're going to write it as aqueous. Might have a little cloudiness. And we're going to switch these cations. So I'm going to switch the barium with the H+. When I do, I'm going to get barium nitrate. Barium is a +2 ion, nitrate -1. So I'm going to need 2 nitrates. Nitrates are always soluble, so that's aqueous. Plus, H+, interacting with OH-. Doesn't matter if there's 2 here. This 2's here because the barium is +2, not because there's an OH2. Okay? So H+ and OH- makes H2O. That's a liquid, not aqueous. And obviously we're going to have 2 H2Os produced from 2 nitric acids.